Right, okay, so this next one, we've got some indices going on here. Whenever you've got this whole thing in a bracket cubed, you can deal with every part individually. So I'm going to have 3 cubed, I'm going to have x squared cubed, and I'm going to have y to the power 4 cubed. So 3 cubed is the result of 3 times 3 times 3, which is 27. X squared cubed, I multiply these indices because this was in a bracket, so that's going to give me x to the power of 6, and the same with the y to the power of 12. For part B, it's if you get terms like this on a fraction, you should be looking to factorise and then cancel. Now the top one is going to factorise into a quadratic. I've got a squared term, a square number, and they are joined by a minus sign, which means that this will factorise using the difference of 2 squares. So it's going to go into double brackets, there will be 1 plus and 1 minus, and then I find the square root of x squared, which is x, and the square root of 9, which is 3. So that's the top part done. The bottom part isn't quite as easy because it's a squiggles one. So I'm going to start off by multiplying the outsides. So I do 2 times minus 3, which is minus 6. And then I look for numbers that multiply to make minus 6 and add to make 5. So in this case, I will need a positive 6 and a minus 1, because that will give me minus 6, and then when I put those two together I will get a positive 5. So I rewrite this using those values. So I'm going to write 2x squared, then I'm going to put plus 6x minus 1x minus 3. Then I draw squiggles and I factorise this side into a single bracket, so I can take out a 2 and an x, leaving me with x plus 3 in the bracket. Now this bracket should be the same, so in order to make the terms negative I need this to be a minus 1. So this will complete by putting the 2x and the minus 1 into one bracket and the x plus 3 into the other. Now when I put that back into the fraction, you should be able to see that there's an x plus 3 multiplying on the top and 1 on the bottom, so I can cancel those out, and then the simplified answer of x minus 3 over 2x minus 1 goes there. Question 15 asks you to prove that the sum of 3 consecutive even numbers is always a multiple of 6. So to ensure they're even, I'm going to write the term 2x, because that means that's definitely an even number. And then I'm going to add to that 2x plus 2, which would be the next consecutive even number. And then I'm going to add to that 2x plus 4, which would be the third consecutive even number. Now if I collect the terms here, I get 6x plus 6. And you should be able to spot that I can factorise that, making it 6x plus 1. So that means that it doesn't matter which even number you start with for x, it will always be a multiple of 6. Question 16 was really just to give you a bit more practice at factorising. So again, we've got 3 terms, there isn't a common factor for each of them. So we are going into 2 brackets. We know it's going to start with a y to give us the y squared, and I want numbers that multiply to make minus 64, and the add to make minus 12. So it might take you a little while to get there. What you can do is a little factor tree for 64. Obviously you can have the mix, you're going to have one positive and one negative. So you can start doing this. So I would have 2 and 32, 3 doesn't go into it, 4 and 16, which does have a difference of 12, So if I had a minus 16 and a plus 4, it would work. Question B was a squiggles one, so I start by doing 2 times minus 15, and that means I have I'm looking for numbers that multiply to make minus 30 and add to make plus 7. So those two numbers are going to be a plus 10 and a minus 3. They will give me that positive 7 in there. So I'm then going to have 2y squared plus 10y minus 3y minus 15. Do the squiggles. I can take out a 2 and a y, leaving me with y plus 5 in there. This bracket should also be y plus 5, so I'm going to take out minus 3. And then to finish it, 2y minus 3 goes into one bracket and y plus 5 into the other. Part C, you start off with this. There is a common factor between 2y squared and 50, so I start off factorising into a single bracket like so. But this isn't fully factorised because y squared minus 25 is a squared term joined by a negative with a square number. So that means that this part will factorise to be y plus 5 and y minus 5, and the 2 will go in front. And the last one here, again we're looking for numbers that multiply to make 36 and that add to make minus 13. Now if they give us a positive number there and a negative number there, they are both going to be negative, and the numbers I'm going to use are going to be y minus 4 and y minus 9. They times to give a positive 36 and add to give a negative 13. Question 17 is about congruency, and congruency is showing that things are the same. Now you are told this is a parallelogram. You know that parallelograms have equal sides in terms of length. You should also know that opposite angles on a parallelogram are the same. Now to prove that triangles are congruent, you could have 3 sides.
You could have 2 sides and an angle. You could have side, angle, side. That means it's the angle between. And you could have a side and 2 angles. The only thing that means it is not congruent is if you have 3 angles, because that does not limit the size. So there's lots of ways to prove that this one is congruent. So I'm going to start off with BD, because this is triangle ABD on this side and this is BCD on the other side, and obviously they share side BD, so they are the same. Then you can either use AD equals BC, because the opposite sides on a parallelogram are the same. You can use AB equals CD, because opposite sides on a parallelogram are the same. So you could use side, side, side. You could use 2 of those 3 sides and 1 of the angles. So for example, ADB is the same as DBC because they are alternate. You could have that, I'll do them with an extra line on, that BAD equals BCD because they are opposite angles in a parallelogram. And of course you can also have ABD, which is here, equaling BDC there, because we have another pair of alternate angles. So within this you need to come up with anything, 3 things. As long as those 3 things aren't all angles, you have proved that it's congruent.